taking a closer look at annuities in terms of amortization of loans and sinking funds. Revisiting the definition of annuity, an annuity is a sequence of payments made at regular intervals. Now we're going to classify an annuity in two different phases. We're going to think of it in the accumulating phase, which is what we've seen so far. So this is when it's accumulating money. It's referred to sometimes as a sinking fund. And then we can also think of it in terms of when it's paying out money. And this is the annuitizing phase. Recall that loans are a type of annuity. Our annuity formulas from the last section are going to be able to help us questions regarding the amortization, in other words, the payments that are necessary to kill the loan to zero, of installment loans such as mortgages, car loans, etc. And now that we know what lump sum of money that we need, we can simply take our present value formula from the last section, so this one here, and we can solve for R, the payment, to figure out what our payments need to be able to fund it. What we knew before was the opposite. We knew what our payments could be, maybe based on what was affordable, and we tried figuring out the lump sums at the end. So taking our present value formula and solving for R, we would need to divide or multiply by the reciprocal of this expression here. So we could get that R is equal to, multiplying by the reciprocal, we would have I over 1 minus 1 plus I to the minus n, and then we've got that P over there with it. So we have PI on top, we have 1 minus, and then 1 plus I to the minus n. So R is still equal to the periodic payment paid at the end of payment period, and N is still going to be your number of payments, still given by the MT, and P is still going to be your present value. So that's going to be like your loan amount typically. And then I is going to be that interest rate per period, which you're used to seeing is R over M. Jumping right on into our first example, a couple secured a bank loan of $360,000 to help finance the purchase of a house. They already had put a $36,000 down payment down. The bank charges interest at a rate of 4% per year on the unpaid balance, and interest computations are made at the end of each month. The couple agreed to repay the loan in equal monthly installments over 30 years. What should be the size of each repayment if the loan is to be amortized at the end of the term? So we're going to round to the nearest cent, and in all future parts we're going to assume the rounded value. Alright, so we can do this both ways. We can use the formula, and we can also use the TVM solver. Let's go ahead and use the formula. We've got the principal amount on the loan is $360,000. We know that they have a rate of 4%, which is pretty good. So 0.04. This is going to be compounded monthly, so M is going to be 12, and it does look like for 30 years. So for our R, we would have 360,000. I, remember, is R over M, and then divided by, we'd have 1 minus 1 plus R over M, and then to the negative MT power. So I have to be really careful putting this one into the calculator. I would probably do all of this calculation first, and then once I get that result, I would multiply by 360,000. But I guess you could go ahead and put the 360,000 out front. That wouldn't really matter. Alright, so we're going to go 360,000 times everything. So I have 0.04 over 12. So there's my first fraction in parentheses. And then divided by, we've got the entire denominator. And then let's go ahead and make sure we get those parentheses there. So this is my entire denominator of 1 minus, and then I've got this in parentheses, 1 plus, I'll have 0.04 divided by 12, and that'll be raised to the, let's go ahead and multiply 12 times 30 to the negative 360. So it looks like that's what I need to get put into the calculator. It looks like I forgot that parenthesis right there. Sorry about that. So we got a double parenthesis right there. So go back up. We got to close this one out. So insert one more right there before the caret, and then let's hit enter. 1718.70. We can do this with the TVM solver as well. Going through the steps, we'd have N equals MT. So M is 12 and 30 years is T. The interest rate, remember we don't convert over to a decimal, it's just 4. Present value is going to be the present value of the loan. And again, I'm pretty sure your book is also doing the same with the payments, keeping those negative. So let's just keep this $360,000 positive, and the payments what you're trying to figure out. So future value, loans always have to be paid down to 0, so that is important. Future value is always going to equal 0. Your payments per year are going to be 12. This is compounded monthly, and we can type that in. So we've got 12 times 30. So go up to payment and do alpha enter. And that's what tells me I need 17, 18, and 70. The great thing about the TVM solver is it also has a balance at a particular time. So you can quit and go to second catalog. So there's a second 0. I've given you the steps right here. So second number 0 takes you to catalog, and it's already got an alpha there. So if you just want to hit B, oh wait, alpha, B is here. B takes you to balance in the green, so it's actually the apps button right there. And hit enter on the balance. So I've got you actually scrolling through to find it. So we want at the halfway mark, so if it was 30 years, we would just do number of months, so 12 months in a year, times the halfway mark for the number of years. So that balance is going to be in months. All right, so they're going to owe a balance of $232,354.08. So if you were refinancing a house or something, that would be some important information to be able to figure out. To find the total amount paid for the house, we can essentially just take our payment that we make every month and do what with it? Well, we can multiply it times the number of months that we're making the payments for, right? Or we can figure that out by taking how many months are in a year and then multiplying it by how many years we are having to pay. So we've got 17, 18, 70, and to figure out how many months, we take 12 times 30. So 17, 18, 70 times 12 times 30. Whoa, we are paying $618,732 for the house. That's just the loan part that we've paid, because we also paid what for the house? Or the couple also paid what for the house? Yeah, they also had a down payment, so that was just for the loan. So their loan amount was $618,732, but they also had a $36,000 down payment. So $618,732 plus $36,000. That's better. $654,732. Now, however, we don't want to include that $36,000 when we're determining the interest, right? Because the loan amount was $360,000, and this is how much we paid. So to determine the interest, we just want to take how much was paid into the bank minus the present value of the loan. So we paid in, or they paid in, $618,732, but the loan amount was only for $360,000, which means the interest paid would be a lot. $258,732 in interest. So that's why they say when you buy a house and you start making your payments, very, very little of it is going to principal. Those first payments go mostly toward the interest. We'll be using this example again in the part 2 video, so you might want to keep it handy if you're going to continue watching.